The broadcast is now starting. All attendees are in listen-only mode.
Good morning and welcome to our webinar today, focusing on the integration of 1D and 3D fluid simulation with Flownex and ANSYS. My name is Brian Miller and I'm delighted to be joined by my colleague Joel Thacker. For any of you who are not aware of wild analysis, we've been around now for around 35 years, focusing on providing simulation, safety and reliability, and design and optimization solutions to now over 1,500 clients. These solutions comprise of leading computer-aided engineering software, supporting training services, and also consulting. Within our company, we have around 55 staff and associates, and all our work, our project work and software is supplied in accordance to various quality standards, including 9001, and also an environmental management standard as well. When we talk about our software solutions, we are a value-added reseller for 7 primary products, ANSYS, which is of course a leading solution for structural mechanics, fluid dynamics and electromagnetic simulation. Flownex, also the theme of today of course, which is a focused product on 1D thermofluid simulation. Plaxis for soil and structure interaction problems. We also have a lot of experience in simulating manufacturing processes using with Deform for metal forming and heat treatment, and Mold Flow for injection molding plastics. And finally, we, through our design optimization solutions, also help customers improve the reliability and robustness of their products and processes, and we help to achieve this through the use and provision of Optimus and Reliasoft. Okay, I'd like now to hand you over to Joel, who will talk in more detail on the theme of today's presentation, which is Flownex and ANSYS.
All right, thanks, Brian. Good morning, folks. Right, okay, so what we're going to talk today about is Flownex and how it couples to the ANSYS solver, mainly Fluent. I'm going to talk about an introduction to Flownex, tell you what 1D CFD is all about. We'll go through some of the GUI in Flownex. In order for Flownex to work with ANSYS, we need to talk a little bit also about journal files, because that's what drives the Fluent solver from Flownex. We'll look at some examples where we set up multiple components and link it to ANSYS and to Excel. And then we'll do a sensitivity analysis and an optimization scheme to see how Flownex and Fluent can couple for trend analysis or optimization also. Okay, so why Flownex? Why 1D CFD in the first place? One thing I want to mention over here is that 1D CFD is not in competition with 3D solvers. It's actually complementary to 3D CFD. There are times when 3D CFD is great, especially if you want to pick up on the minute details of the flow within a component. But if you're looking at a system level design, a plant design, or components spread across a large geometric space, CFD is just not the tool. The advantage of 1D CFD is that you can get quicker turnaround times because you don't have to deal with mesh, and it's all network based. Also, because the solver is faster, you can look at things like sensitivity studies, over a wide range of operating conditions, and also optimization over several variables and several target variables. So I've got an example over there that you can see where Flownex is used for system analysis, where you've got valves, you've got heat exchangers, you've got orifices, you've also got control, PID controls, and you've also got dynamic control via dials and via slider bars, basically, where a valve can open or close based on the user input. This is something you cannot do in CFD very easily, and this is where Flownex and 1D CFD come to their own. Flownex as a software tool has a wide array of industries and physics capabilities. So whether you're modeling pressure drop, single-phase, multi-phase analyses, transient dynamic analyses, the onset of cavitation, thermal management, sonic, supersonic flows. Flownex can handle that quite easily. We have our own set of libraries that come with the software, that are inbuilt with the software, for pipes, for valves, for orifices, for heat exchangers. Some of the components are taken from classical references like Miller, Crane, Idlecheck. But then we've also got libraries that you can generate by yourself, and those can be saved to Flownex, so you can pull them up later for another analysis. Obviously, the theme of today's webinar is linking to external software. So besides ANSYS, we can link to Excel, MathCAD, Relap if you're in the nuclear industry, and also script for specific variables that you might be interested in. Okay, like I said before, 3D CFD is best suited for component level analysis. Looking at the example in the bottom left over there, if you were interested in the details of the turbulence and the separation and the recirculation, then yes, 3D CFD is definitely the way to go. However, if I take the same component and I want to put it into a network and see what the effect is, such as that, you can see, once I've started including fans, PID controls, a valve with a closure and opening delay, 3D CFD is going to struggle because, the time and the computational resources required to do that are just too big to make it practical. So you could do a network analysis where that component on the bottom left is modeled as a component in Flownex that's highlighted in red. Alternatively, if you use ANSYS in conjunction with Flownex, you're making the best of both worlds. So the majority of your network is solved in Flownex, but then that one component, you can either model it as a component in Flownex, or if you want the details of that captured, you can model that in ANSYS and then couple it to Flownex like I've shown over there. Okay, so real-world applications for Flownex, secondary losses. If you're in the turbine industry, the compressor industry, or in the sealing industry, this is something that you might be interested in. How much leakage do I have? Flownex can model such things quite easily through labyrinth seals, through radial seals, in a dynamic or steady-state fashion. Flow balancing. I need to have X amount of flow going through a specific branch within a network that is controlled by, let's say, valves or something else. I have a target flow rate that needs to be delivered. Flownex can be used to optimize your geometry and your operating condition to deliver that target. And then, of course, you've got your dynamic analysis over here. So this is a case study that was done for a data center where, as you can see, the valve at the bottom right is opening and closing based on user input. But then we've also got a knob, a dialer at the top right, I guess, which we can control dynamically, and that'll affect the solution. So this is great to also see, on the fly, what happens if there is a shutdown or a fault. How does the system respond? How long does it take the system to respond? And what measures and countermeasures do I need to put in there to make sure there's no failure? When you open Flownex, this is what it looks like. It's a Windows-based GUI. It's a clean GUI. It's all based on drag and drop technology. So, for example, if I want to pull in a pipe, I go to the Flownex library, go down to the piping section, grab a pipe, and simply drag and drop it onto the canvas. I can extend the pipe as much as I want, really, on the layout for layout purposes on the canvas. One good thing about Flownex is that you can edit properties either on the canvas or in the details window. So I'm going to put some parameters, drag some parameters from the properties window directly onto the canvas. In this case, I want to take length and wall thickness and drag that directly onto the canvas. Now, I can change, like I said, the properties directly on the canvas, and they should update on the details window. So in this case, if I update the wall thickness on the canvas, if I go to the details window, you can see that's been updated. Similarly, if I change the length in the details window, that's updated on the canvas. This is obviously good because someone who doesn't want to dig into the details window can edit it quite easily on the canvas. If I wanted to change the units, from meters to centimeters or imperial to metric. That's quite easy to do because Flownex handles that quite easily. I can add in more components or a boundary condition. So if I take a boundary condition, again, it snaps onto the existing component. And in this case, I'm going to keep it as a mass flow boundary condition. I'm going to give it some value, and again, going to take that mass flow value onto the canvas. I can position it again wherever I want, and I can also change the number of significant figures, to 2 decimal places. So change that to 2 decimal places. And again, if I'm working in different units, as might be the case in the oil and gas industry, I can change that to gallons per minute or any other units quite easily. If I wanted to add another pipe component, I go to another pipe, and again, it's a matter of snapping on to the existing components. So again, as you can see, it's quite easy to build a very complex network based on the drag and drop technology. The fact that you don't have to go into the details window again is quite inviting, because someone who doesn't know Flownex can easily come into that analysis and simply edit the model based on the canvas input over there. They don't have to go and dig into the components level window. Okay, coupling to Fluent. When you couple Flownex to Fluent, you're not limited in the capabilities of Fluent. You're getting the full range of Fluent capabilities. So all you're doing over here is just coupling the two solvers. That's all that's happening over here. In order to make Fluent run in Flownex, we work with journal files in Fluent. And what that is really, a journal file is just a list of ordered actions that we tell Fluent to perform within the Flownex environment. So in this example over here, we've got a diffuser type section where we open Fluent, edit the inlet velocity, initialize, solve, save the data, and then export a parameter, in this case mass flow rate, to a file, which is going to then be picked up by Flownex. Okay, so this is Fluent. For those of you who are familiar with Fluent, go to File, import our case study. Of course, before we do that, we need to open and we need to start a journal file. So that's what I've done here. I create a journal file in a directory of my choice. So I'm just going to call that test journal file. It can be a text file. Once I've created that journal file, it's recording all these actions now. So I open the case first. And the case consists of the mesh, the boundary conditions, the turbulence models. That's my geometry. Right, okay. So it's got the models already. If I go down to boundary conditions, you'll see that inlet is a parameter. And it's important that it's a parameter because that parameter is obviously going to change based on what we input into Flownex. So if you go to parameters within Fluent, you'll see currently it's listed at 2.5. I'm just going to change that to 3.0. Okay, close that. So once we've got that, we just initialize the solution in Flownex, and then it's a matter of run calculation. So nothing new over here for those of you who are Fluent users. All we're doing over here is just recording all these actions for a journal file. I've set it up to run for 50 iterations. Once we've got the result, I'm going to export the mass flow rate at the outlet. So I'm going to compute that first, and then I'm going to write that out to a text file. And this text file is going to be picked up by Flownex. Just going to call that results. Hit OK. And the last thing I'm going to do now is going to save the case and data file. So once I've got that saved, I'm going to call it a test run, case and data file. Right, and then exit Fluent. And all these actions now have been recorded. And when I put Fluent into Flownex, Flownex will drive Fluent in based on those actions. So I've got an example here where I've got Excel driving Fluent, and then the results of that are driving a network in Flownex. Again, this is something you just wouldn't do using 3D CFD, because you've got turbines, you've got compressors, you've got two different valves, and you've got piping sections between them, that can be quite long. The mesh and the computational resources required to do this would just be too big to make this a starter for CFD. Like I said, the input to Fluent is an Excel file that you see based on the Excel icon. So we're going to give it some velocity inlet that drives the Fluent component. All this is within the Flownex environment. So if I go to the Excel component first, you'll notice that I've got a velocity inlet of 11 meters per second. And that's based on the output variable in Excel. That's what's going out of Excel, so it's an output. And in Fluent, I refer to the journal file that I created earlier, the text, about text. And then I tell Fluent to look for that line which in the journal file which inputs the velocity. And the velocity is then done via that link which I just pointed to. And then we take the mass flow rate out from the text file that the journal file created and put it into the Flownex network. Okay. The actual link is shown here, but I'm just going to create that again just to show you how easy it is to create a link between Excel and Fluent. So it's a matter of going to data transfer link and copying the value of the inlet velocity from Excel to the input part of the Fluent journal file, which is right there. So there, copy and paste it. There's no adjustment to the value. And that is it. That is my link complete between Excel and Fluent. If I run the software now, it opens up Fluent. Fluent goes to the journal file of opening the case and data file. It'll update the velocity based on what's come out from Excel. It goes through 50 iterations. It saves the case and data, spits out the mass flow rate, and that mass flow rate is then sent to Flownex. That mass flow rate is picked up there and then sent to Flownex in the downstream network. So a couple of things to take away. Firstly, how easy it was to set up the network analysis link between Excel and ANSYS, but also the speed in which you actually got a result from a pretty complex network analysis consisting of turbines, compressors, and valves, multiple turbines, compressors, and valves. Again, you would not be able to do this in that speed using 3D CFD. So combining 3D CFD and Flownex is a very powerful tool. Okay, building on that then, in some cases, we want to know more than just an answer, what happens at a single condition. Very often, we want to know a trend or a behavioral pattern. We want to pick up on those for a component or for a system. And that's where a sensitivity analysis comes into play. So I've got a simple example over here. Again, ANSYS is driven by Excel. And then all we're going to do over here in the downstream pipe, we're going to monitor what happens to the downstream pipe temperature, the fluid temperature in the pipe downstream, as a function of the inlet velocity that's going into Fluent. So how do I set that up? If I go to my configurations, the sensitivity setup, I add a new setup. I can have a Monte Carlo simulation if I wanted to, but in this case, I'm going to keep it to a parametric steady state analysis. I take my velocity, which is my input value, my input variable. I give it some nominal value, a low value, and a high value, like so. And once I've done that, the parameter that I'm monitoring, I set it to first to a parametric run of 8 runs. And then once I do that, the parameter that I'm monitoring is the static temperature downstream in the pipe. So again, I highlight the pipe and just grab that property, the static temperature, into the results. That is it. That's my sensitivity analysis done. If I run the sensitivity analysis, you'll see the plot being updated as the solver is running. So again, runs very quickly. And this is great to know, what what's happening to the system as you change a boundary condition. It's great for what if scenarios. It's great to get behavioral trends, especially in complex systems where it's not obvious what's the driving factor, what's the driving variable. If you've got a bunch of valves, if you've got multi-phase flow that has maybe phase change, it's not obvious what's gonna what variable is actually the important variable. So this, using a sensitivity analysis, will highlight the important variables, but also their order of importance. So when it comes to trade-offs, you know what you can sacrifice and the degree to which you can sacrifice a certain variable or parameter. Building on that, most of the times we also like to say, well, okay, I know how my system is going to behave, but can I force my system to to deliver a target value of mass flow rate, for example, or temperature or pressure drop? And Flownex allows you to do that in a coupled environment or in standalone Flownex also. So in this case over here, I'm using the same example. I've asked Flownex to deliver a downstream temperature of negative 0.183 Celsius. And you can see from the graph over there, it starts off pretty broad. It spans the entire range of the design space and then starts converging and honing in to an operating condition that provides you with negative 0.183 Celsius in that pipe. And that's done dynamically. And what you see over there on the screen are the boundary conditions that will offer you that that temperature in the downstream section. Okay, to summarize then, Flownex, hopefully you've seen, is an easy to use GUI. It's based on drag and drop technology for components and also for properties and parameters. It's a system level analysis, strictly speaking, but it can be coupled to a detailed 3D CFD solver. As I mentioned before, 3D CFD is great if you want to capture the details of a component, but it's really impractical for large systems, especially if you're going to do a transient simulation. 1D CFD is, on the other hand, quick to set up, and it's ideal for large networks. There might be cases where you want to capture the details of a specific component, but then link it up to a bigger system. And for that, the combination of 1D and 3D CFD, like I've shown up here, is the best way forward. You're making the best of both technologies. Flownex as a software itself is catered towards the expert or novice user. You've got, the ability to script your own variables, but then you've also got the ability to drive the entire simulation, whether it's Flownex standalone or Flownex coupled to another solver like Fluent, entirely from Excel. So someone who doesn't know Flownex or 3D CFD can just walk into Excel and drive the analysis from there by updating the parameters. And lastly, it's more than just a single answer. You can identify trends, you can identify behavioral patterns, and also understand, what needs to be done to reach a target value for a certain parameter that you're interested in. I'm going to pass you back now to Brian, who's going to close up and talk to you a little bit more about our other activities.
Okay, thank you, Joel. We'll be running a question and answer session in a minute. So just as a reminder for anybody who would like to ask a question, there's a panel within your GoToMeeting screen where you can easily type a question and we'll address it hopefully in a minute. Just before then, I would just like to just point out a couple of other upcoming events which you may be interested in on the related topics. Firstly, we're running a webinar on the 3rd of June focusing on some industrial case studies where we've actually used the ANSYS CFD to help some clients optimize their product designs. That's using some both parametric and mesh morphing capabilities within ANSYS to try to improve and hone in on the best design solutions. We're also planning a live workshop in mid-July, on the 16th of July, and this will be a chance for any of you who are interested in 1D fluid simulation with Flownex to actually have a go yourself. It will be a day of some theory lectures and also some tutorials where you get a chance to actually use the software in our offices with the support of our engineers. Places are limited on this particular event, so I would encourage you to register as soon as you can to obviously secure your seat. For more information and to register, then please just visit our website, wireanalysis.co.uk, and look under our events page. Finally, before taking questions, we're always interested in running other webinars which may be of interest to you on a technical or on a software level. So please feel free to suggest some future topics which we may be able to address and put on over the summer and beyond. Okay. So, just before taking questions, if there's anything you would like to ask us about today, which you prefer to do offline, then please contact us any time on the email address and number shown on the screen here. And of course, if you would like to find out more about Flownex and ANSYS, we'll be happy to come and give you a personal demo, or, as we discussed before, maybe attend a workshop. So, just looking at any questions. Okay, we got the first one here, Joel. Obviously, we focused on Fluent today. Does Flownex couple with any other codes?
Yes, absolutely. As I mentioned before, Flownex can obviously couple to MATLAB if you're using that, but also other 3D solvers like StarCD. So yes, it can do coupling to other 3D CFD solvers.
Okay. In fact, I've heard that the API is pretty flexible, so
yeah,
perhaps try and
absolutely.
it's something which isn't supported at the moment. We may be able to help link to it anyway.
Yep.
Okay. The example you've shown is steady state. Can we do transient?
Absolutely. We can, add in valve closure opening in a transient fashion, and then again couple that to Fluent or to any other 3D CFD software. So yes, transient analysis in Flownex standalone and Flownex coupled to some other solver can definitely be done.
Okay. And finally, final question. I am a Fluent user at the moment, so obviously I'm experienced in CFD. How long would it take me to learn Flownex?
Okay, so the standard training is 2 days, but I mean, we really find that most clients are pretty good at learning the software themselves, really, after a day or so, because really it's all drag and drop technology. And within, a week or so, they're up and running on fairly complex network analysis. So we're obviously here to help you if you run into any troubles, but for your basic, network analysis, I would say within a week, you should be getting viable results.
Okay, that's great. Okay, well, I think that wraps up the questions we have in front of us. So just as I mentioned before, please get in touch and we can perhaps talk to you further about this technology. Okay, thank you for your time.
Thank you. Bye-bye.